Okay, program number 4. I'm going to make a new file, copy and paste my pragma code from the previous one. And number 4 says press a bump switch and both motors come on for 4 seconds and then stop. So for this one, we have added the bump switch. So once again, thinking sequentially, the first thing that has to happen is pressing the bump switch. So I'm going to go ahead in my pseudocode, say press bump switch. And once the bump switch has been pressed, I'm going to turn on the left motor and turn on the right motor. These motors are going to turn on for 4 seconds, so I'm going to have a wait 4 seconds. And then finally, after the 4 seconds expires, I'm going to turn off the left motor and turn off the right motor. Okay, so that's, once again, my pragma. Looks good. Organized my thoughts. And so now I'm going to move on to my task main. So this is going to be a switch. And so I'm going to use my until bump command right here. So this is something new. And I'm going to drag until bump over here. And the sensor port that I'm referencing is my bump switch, which is up here in my pragma on line number 4. Notice it's lowercase b, uppercase S for switch. So I'm going to type in bump switch. And then I have a delay time. And a lot of people don't really understand what this delay time's for, but it's to give you as a human a little bit of time to release the button after it's been pressed. Because if you don't have this delay time, then what happens is the code runs so quickly, so it goes on off so fast that it doesn't even register to you that it ever turned on. And so I'm going to put in 200 milliseconds. So this is 200 milliseconds to give you just a fraction of time to release that bump switch so that you can activate the next portion of the code. And so the next part of the code is turning on the left and right motor. So I'm going to go back to movement and I'm going to drag over start motor twice. I've got my wait, so I'm going to grab wait. And then I need to stop both of those motors. So stop the left and the right motor. I'm going to clean this up a little bit. Remember, curly braces get their own line. And the motor port, left motor, speed. Let's see, didn't designate the speed, so it can be whatever you want. Usually I just default half power. My wait time was 4 seconds, and then I'm going to turn off the left motor and turn off the right motor. So that is program number 4. I'm going to compile it to check to make sure I don't have any errors. And when you compile it, it's going to say you need to save again. So I'm going to go back to my desktop. Programs. I'm going to click on program 3 so I don't have to type out program and change that 3 to a 4. And so now across the top, oh, I have an error. That's good. Did I spell something wrong? SW, yep, I spelled switch wrong. So this is actually a really good example of why you should compile your programs all the time. Notice my switch, I spelled it wrong. So SW, I've got the T and the I. So now whenever I go back to compile, my error is gone. So that's why you compile all the time, to make sure everything is working the way it needs to.